Hey everyone, this is Group 7, and we're doing Chapter 7 How to Design Our Organization and Architecture with Conway's Law in Mind. In this chapter, we will be thinking about how to organize ourselves to best achieve our value stream goals. With a well organized team comes competent work results. Um, Dr. Melvin Conway performed a famous experiment in 1968 with a research organization that had a team of 8 people with a goal um, to implement COBOL and ALGOL compiler. COBOL is a compiled English-like computer programming language designed for business use. It is imperative, procedural, and since 2002 object-oriented. ALGOL is a family of imperative computer programming languages originally developed in the mid-50s, which greatly influenced many other languages and was the standard method for algorithm description used by the Association for Computing Machinery. Conway's law is basically the larger an organization is, the less flexibility it has, and team organization has a major effect on the software we produce. Etsy is a major example of how Conway's law can either impede or reinforce our goals. Etsy developed Sprouter, and its goal was to connect development teams, but it came with undesired outcomes. Development teams were supposed to be able to implement PHP in the application, and DBAs or database administrators were to be able to write SQL inside Postgres, with Sprouter being able to help meeting them in the middle. Ultimately, this failed, and in 2009, the new CTO of Etsy, Chad Dickerson, made it a goal to eliminate Sprouter, and he implemented site stability, had developers perform their own deployments into production, and in 2 years eliminated Sprouter. There are 3 major organization archetypes. First, the functional archetype focuses on optimizing expertise, the division of labor, and reducing cost. Second, the matrix-oriented, with a focus on combining functional and our next archetype market, but often resulting in complicated organization structures. Then there's third, we have market-oriented, where the focus relies on responding quickly to customer needs, and it often tends to be flat with multiple cross-functional disciplines, which lead to redundancies. Moving into problems with an overly functional orientation and how we can be optimizing for cost. Here we will organize according to specialty. There are often long lead times, and most developers will have little visibility with how their work relates to the value stream as a whole. With multiple value streams, there will be more problems, and lastly, teams will also have trouble keeping up due to lack of communication and other functional problems. When we optimize for speed, we enable market-oriented teams. We can optimize for cost by reducing the effects of the functional orientation in the previous section. Thus, in turn, enables the market, which optimizes for speed. The market teams are responsible for future developments, testing, QA deployments, and future supporting services with products after they've left development. See the Netflix and Amazon model for an example. Amazon states especially that this method is the reason they can move fast and continue to grow. To achieve market orientation, we won't do a large top-down reorganization, but instead we will embed the functional engineers and skills into each service team or provide their capabilities through the automated service platforms that perform production-like environments, initiate tests, and perform deployments.
Now, ideally, the goal that the business wants to do is to get things done with minimum to no casualties. And cross-functional and market-oriented teams are one method to achieve a fast flow and reliability. The hard part about it is that when you have high fast flow work, the reliability gets low, and then also the costs would get high. And it's the same the other way around. Like the the reliability might be a lot higher, but also the cost would be higher in order to achieve that. But The desired DevOps outcome to achieve is through the functional operations. In such, the high performance with a functional oriented and centralized operations group is a possibility as long as the service teams get what they need from their operations reliably and fast, and it works the other way around. When you when you do these tasks at a fast and reliable rate, you would develop this sort of trust. And DevOps uses this high trust culture, which enables all departments to work together effectively and efficiently. And since everyone is part of a team, everyone within that team shares a common goal. And this goal could be addressing like some of the most urgent problems of the day, be it working on or deploying a certain customer feature or fixing a severity production incident, or it could be something even more urgent than that. But according to Jody Mulkey, he describes that using a football analogy, that ops are the offensive linemen and the devs are the skilled positions such as quarterback, fullback, the guys in the back, pretty much, who whose job is it to move the ball down the field. And the only way they can do that is that the ops' job is to help make sure that they are well protected and also make sure that the devs have enough time to properly execute their plays. And now one thing that DevOps strongly encourages is that every team member should be a generalist. You've heard it several times. What is more important, being a specialist that is only good at one thing, or a jack of all trades but is a master of none? Well, with Scott Prue, by cross training and growing engineering skills, it turns out that the generalists can do more work orders at a large magnitude compared to their specialist counterparts, and in doing so improves the overall workflow by removing the queues and wait times that go along with them. DevOps wants to encourage learning. They want to help everyone overcome any form of learning anxieties that they encounter, and to ensure that they obtain relevant skills and have a defined roadmap in their bright career in the future. So another important thing is that the the funding shouldn't just go to the projects; they should also go to the services and products. When we create a stable service team with an ongoing funding, it allows the execution of strategies and their own work roadmap of initiatives, which also the teams have a dedicated engineer needed to deliver on the commitments made to the internal and external customers, such as the features, stories, and tests. Now, this is kind of the opposite of what it was traditionally, because teams are always assigned to a project, but once that project is done, or the funding runs out of it, like there's no more money, then they just move on to a new project. DevOps declares this method as undesirable because doesn't give the developers any feedback on their previous projects, and then the funding model itself, it only plans for the initial stages of the software's life cycle and not the overall stages of it. So it is important to do a product based funding model in which the product itself or any of the value stream is is an achievement of the organizational and customer outcomes, be it the revenue, the adoption rates with minimum output, or just customer satisfaction, so that those that gain trust in the product will be able to be returning customers, or sort of develop a fan base to, that will build a business's reputation.
Team organization is an essential aspect of any organization. Designing the boundaries of a team in accordance of Conway's law is a good place to start. A habit many organizations have is splitting up teams. An example is by function, which increases the amount of coordination required from everyone, which results in higher amounts of rework, handoffs of projects that don't go very smoothly, and people not currently working on a project just waiting around. In an ideal world, small teams should be set up independent from each other with all the different roles needed inside that team. This removes unnecessary communication and coordination, which can increase productivity. Okay, on to the next slide. We build on the idea of the benefits behind smaller, more independent teams. So tightly coupled architecture refers to a system in which the process to make any change requires a very high amount of communication and coordination. And because of that, deployment times get very long, because of the need to create testing environments to make sure that changes won't negatively impact the rest of the system. This is where, again, the benefit of smaller independent teams come into play. Because the smaller teams aren't coupled into a tightly knit system, the teams can quickly implement, test, and deploy code into a production environment, resulting in increased productivity and improved deployment times. An example of one of those systems would be SOAs, or service-oriented architectures, these loosely coupled services being independently testable and deployable. Continuing on to the next slide, building on the loosely coupled architecture system, one of the main benefits is the ability to update in production without having to worry about updating other services. This does require services and databases that are shared to be decoupled, though. Another benefit of this is that the developers don't really need to understand and know what's going on in the peer system's code to build on their own system. To do this, we use APIs, which removes the sharing of data structures and other objects. Google and Amazon are two huge companies that utilize these methods. Alright, so on to the conclusion. Looking back at the Etsy study is a prime example of how architecture and organizational design can dramatically alter our outcomes. Conway's law, if implemented incorrectly, results in poor outcomes for the organization. However, done correctly, results in the much easier development and testing of product, which will result in value for the customer. Thanks for watching.